All right, guys, let's go ahead and discuss significant figures because, gosh darn it, they are significant. So sometimes when you're making measurements in the lab, say you were measuring the mass of some object, your numbers will vary because the instruments that you have are not perfect. So for example, on the scale, perhaps you measure that the mass of this object is 4.23 at one moment. But if you give it a little bit of time, it ranges up to 0.431, and give it even more time, and it ranges back down, all the way down to, say, 0.416. You see, there's a lot of variation in the measurements recorded on the instrument. This 3, it runs up to 9, and then even up to 1, or it runs down, let's see, 7 or so. These digits are highly variable, but there is a digit that is constant and another digit which is somewhat variable. It's going up or down 1, but in general you can have a fairly good idea of the value of your mass. You have a fairly good idea that the value of the mass is 0.42. And so basically we want to account for how good our understanding is of the mass by just reporting any numbers that we solidly know and then a number that maybe ranges up or down 1. And so what you would record is just 0.42. You would record this as the mass in your lab. We have a certain number of significant figures in our measurements so that anyone who reads our measurements has some understanding of how thoroughly we understood that mass or volume, etc. And then we later do calculations from these measurements. And we need to keep track of those significant figures as well. So before you do calculations, keeping track of the number of significant figures in your measurements, you want to just be able to firmly say how many significant figures are in certain numbers. So at a first point, the question is how many significant figures are in 423? Well, turns out all non-zero integers are significant. So how many sig figs are here? 3 sig figs. Okay, what if you had some number, say 4023? How many significant figures would there be? Recall, all non-zero integers are significant. And what about a 0 in between non-zeros? That counts too. And so here there are 1, 2, 3, 4 significant figures. Try another one. What if I gave you a number 402,000? Okay. How many significant figures are here? Well, yes, non-zeros are significant, but so are zeros in between non-zeros. But what about zeros to the right of non-zeros? They are not significant. So we only have 3 sig figs in 402,000, but what if I gave you a different number which was only slightly different, 4.02000? Well, yes, the 4 and the 2 and the 0 in between them are obviously significant. And what about all these other zeros? They are significant because there is a decimal anywhere. Yes, zeros to the right of non-zeros are significant if there's a decimal anywhere. So try another one. What if I gave you the number 0.003010? Which numbers here are significant? Well, definitely the 3, the 0 in between the 3 and the 1. So definitely this, and that. What about this 0? It's to the right of non-zeros. And there's a decimal, so yes, this is significant. What about these other zeros? Well, they're to the left of these non-zeros, and so they are not significant. And so how many sig figs are here? 4 sig figs. How many sig figs were in this value? 1, 2, 3, 4, 5, 6 sig figs. Okay. So that's how we know how many sig figs are in certain numbers, and we can use that number of sig figs in calculation. Say you wanted to, let's say I gave you a certain length of an object, which was 4.02 centimeters, and another length of that object in the other dimension was 7.561 centimeters. And I asked you to find the area, which you know is length times width. So you need to find the area. You need to multiply these two numbers together, keeping track of how thorough your understanding of these lengths was. And so what you want to do is consider how many significant figures are in these numbers. So how many sig figs are here? 3. How many sig figs are here? 1, 2, 3, 4. So how many sig figs should be in your answer? 3 plus 4? No. When you do a multiplication or division, you want to use the smaller of the number of sig figs, because the answer of your multiplication or division, its precision is dependent upon how precise your measurements were, but really the least precise of all your measurements. And so you should have only 3 sig figs in your answer. Now, your calculator might spit out, if you plug in 4.02 times 7.561, your calculator might spit out 30.3952. Now, this is not what you should write after you've done your calculations. This is not what you should write on a test. What you write on a test should have only 3 significant figures. And so instead of writing all of these things, you need to write an answer that only has these 3 sig figs, which means that you're going to basically cross out everything else to the right. But I guess one issue is when you're crossing out all these other guys, sometimes you need to round the rightmost of the remaining figures up, or you need to leave it. Now, you'll round this guy up if the preceding number is 5 or greater, and you'll leave it as is if it's 4 or less. But this is 9, so it's 5 or greater, so you'll round this guy up. So in fact, what you'll write is 30.4. This is the number you need to report on a test or in the lab to signify your best understanding while also accounting for the number of significant figures, letting me know how thorough your understanding was. And so that's multiplication or division. We want to keep track of just how many sig figs there are. But if you're dealing with things like addition or subtraction, then the rules are a little bit different. Instead of accounting for the number of sig figs, you need to just account for the significant figures in reference to the decimal, basically their place. So let's say that you were to add a very precisely understood number to a not very understood number. Well, you would get the following. Now, how many sig figs should you have in your answer? Now, you might say, oh, your answer should have 2 sig figs because, oh, there's only 2 sig figs in the least precise number. However, in addition or subtraction, you don't care about the number of sig figs. You care about the least significant place with regard to that decimal. So we lose our understanding of this guy right after the 10th place. And so we cannot, in our answer, include anything to the right of that tenths place. And so you need to write 11.9. You don't round this 9 up because this guy is 4 or less. Okay, so 11.9. And so let's see. Isn't it strange that we had in one of our guys we had 2, 4, 5 sig figs, and in another guy we had 2 sig figs, but in our answer we actually report 3 sig figs. Tricky. And I love to use this question. It's one of my most favorite questions. Tricky. Try another one. What if you had a very imprecise understanding of a very large number, say 3,000? So you have a big pile of something and you don't really know the mass. And then you add to it 4.2 grams of more of that substance. So your calculator might spit out this, but what should you report on a test or in the lab? What is the least, or where do we have, where do we lose that understanding of how precise something is? Basically, with regard to our decimal, we don't really have a precise understanding until we're in the thousandth digit. And so, whereas you might want to say 3,004.2, in fact, what you need to record is 3,000, because we still only have one significant figure beyond where we should. So, isn't that funny? We have a very imprecise and large number, and then we add a precise measurement, and nothing changes. Well, you can look at it this way. This 3,000, we don't really understand this 3,000. It could range anywhere between 3,500 and 2,500. And so, because we have such a poor understanding, you can't just add this small amount and then have a great understanding. We still have a poor understanding, and adding this small amount doesn't change anything. So record 3,000. All right, guys. Thanks for watching.